Hello everyone. So here we are back with another important topic, Thevenin voltage and resistance, or a Thevenin equivalent of a circuit. So as you see in this problem, it is asked to find the Thevenin voltage and resistance of the given circuit. Now what is this Thevenin voltage and resistance? First let me explain that and then we will solve the problem. So what is this Thevenin equivalent? So Thevenin equivalent is basically a simplified form of a complex circuit. Now this circuit can be of any form and it can have any number of dependent and independent source, load, whatever, but we can simplify it with just a voltage source and a resistance. So whatever circuit we will have, we can just convert it to a voltage source and a resistance. So this is our Thevenin equivalent. It can be anything in this side. So this voltage we will call Thevenin voltage and this resistance is we call as Thevenin resistance, RTH and VTH. Now why do we need this Thevenin equivalent? So basically, suppose we have a complex circuit here, okay, and we have the output of this, like there is a 2 terminal here and we connect some load here, okay. So now if we need to find the voltage and current through the load, so then we have to calculate this whole circuit, yes, but if this circuit is very complex, then the calculation also becomes complex, and any change in load will make us do the calculation again and again. So instead of doing this complex calculation, if we have a simple circuit like this V and R, like VTH and RTH, then we can easily find the voltage and current through the load, right? So that's why we need this Thevenin equivalent to reduce the calculation process of a complex circuit. So how to find the Thevenin equivalent? So you have to remember this 4 point. So first one is remove the voltage source, or you have to short circuit that. Remove the current source, or you have to open circuit that. So these two actually is talking about independent source. Now if you have a dependent source, then the method is a little bit different. So to find the Thevenin voltage, you have to just apply simple calculation, like you don't have to do anything. These steps are to find the Thevenin resistance, okay. Thevenin. In case if you have a dependent source, don't do anything with the dependent source, leave it as it is. Then connect but you have to remove the independent sources, okay. Then connect a voltage source or current source at the output terminal where we are finding that Thevenin equivalent, and then you have to find the voltage and current from that terminal, and then you will be using that R is equal to V upon I, and you will get the Thevenin resistance. Now you will have a better understanding when we will solve the problem. So coming back to the problem, so here as you see we have a dependent source, that is VAB upon 4, that is a dependent current source, right? And we have a independent voltage source of 9 volt. So let's first find the Thevenin voltage. So this is our circuit. Now in this part of the circuit, will there be any current? No, because this is open, this side is open circuit. So whatever voltage we will be having here, that is VAB, here also we will get the same voltage VAB, right? So if we think that this side is grounded, so at this point we will be getting a voltage VAB, right? So now we will be using KCL at this point. So you see there will be two current, one is flowing from this side and one will flow from this side. So this current is clear, it is written as VAB by 4. So this is, since this is entering, we will be taking it as positive, so plus VAB by 4. And what will be the current in this side? So you see the current is basically V upon R, right? So whatever the voltage difference at this point is there, that divided by 2 ohm will be the current. So that will be, if we are thinking that current is flowing from this side to this side, so this 9 volt is larger than VAB. Okay, so the current also will be the voltage difference, that will be 9 minus VAB upon 2, right? So now this is also entering, so we'll take positive here also. 9 minus VAB by 2. Is there any, there is no more current, so this, the sum of these two will be 0. Now if we calculate this, we get VAB is equal to 18 volt. So this will be our Thevenin voltage as well, right? So Thevenin voltage done. Now Thevenin resistance. So first we have to remove the independent sources. So here we have one independent source, that is the 9 volt voltage source. So we have to short circuit that. So if we do that, the circuit will look like this. We have to connect a voltage or current source in this part. So let's connect a current source. We are connecting a 1 ampere current source. So if we know the current source, we have to find the voltage across this part. Then we'll get the resistance. So now let's use some KCL or KVL to find that voltage. You have to find the voltage across here, okay? This. Now you see, can I use KVL here? See, there is a mesh like this. Yes, we cannot use the KVL at this loop. Why? Because we don't know the voltage at this part. Okay, so that's why we cannot use the KVL in that loop, but we can use the KVL in this loop because all the voltage are known. So you see, so that here we will have a current as 1 ampere. Yes, and in this part the current from this side and this side is getting added up, right? So here the current will be 1 plus VAB by 4. Yes, so here, okay, here you have VAB, this side is plus, this side is minus. Okay, now here we will get a voltage, the plus minus, and here also we'll get a plus minus like this. Let's use the KVL here now. During KVL, always try to follow the direction in the current direction. Okay, so minus VAB, if we start from here, since the negative, we are getting the negative side, so minus VAB. Then across the 3 ohm resistor, the voltage will be 3 into 1 V into I into R, right? Then across the 2 ohm we'll get 2 into 1 plus VAB by 4 equal to 0. Now if we solve this, we get VAB is equal to 10 volt. So if it is 10 volt, so Thevenin resistance RTH will be VAB by the current source, that is 1. So we could have taken the current source as any value, but 1 ampere gives us, like, keep the calculation small, and we get the direct resistance RTH is equal to VAB by 1, so basically equal to VAB only, so that will be 10 ohm. Okay, so this is our Thevenin resistance. So this is how you calculate the Thevenin voltage and resistance. Alright, so I hope you understood this problem. In future we will solve this kind of problem again. So if you have any doubt, please write in the comment section. Okay, also to understand the KCL and KVL, if you need, I have given the link of 2 videos in the description. You can check out those videos. Thank you.